introduction to probability. So probability is a measure of how likely an event will happen. So the way that we usually do this is we do number of successes over total attempts. So we saw this a decent amount in like 9.3 and 9.4 when you were trying to figure out like the percentage of, someone making a home run or something like that. So that was sort of an introduction to probability, which we'll talk about more now. Okay, so we have this probability scale, and it can go anywhere from 0 to 1. So it's a decimal or fraction between 0 and 1. So if it's 0, it's impossible. Like, it's never going to happen. If it's 1, it's certain. It's like 100% going to happen. Like, it's going to happen. And then 50% or 1/2 is equally likely. All right. So the smallest value of probability can be is 0. This happens when the event will never happen. Right? The largest value of probability can be is 1. This happens when the event will always happen. Right? So if you like a visual scale, you can look at this. If you like just the numbers, you could just think between 0 and 1. Okay, so let's do a quick test run. Describe the likelihood of an event as impossible, unlikely, equally likely, likely, or certain. So the way that this P, that's like the specific notation. So notation is like the way that you write it. It's like the grammar of math. So if I say P and then just like an event that's happening, that means the probability of the event happening. So you'll see this a lot, P, parentheses, and then something that's going to happen. Okay, so if we were to look at this example, our school closes today because of snow. So the probability of no school. All right, so for this one, right now it's not really snowing. So maybe it would change if we did this in the winter. But the probability that our school closes today is pretty unlikely, right? So we're going to put unlikely. It's not quite impossible, but it's like not looking like it's going to happen. It's pretty nice out. So unless there's some freak snowstorm, school's not going to close. All right, so for number 2, you get a head when flipping a coin. So probability of heads. All right, very nice. This is equally likely. Right? It's half heads, half tails right here in the middle. So the chance that I'm going to get heads, the probability that I'm going to get heads is equally likely. Okay. Number 3, roll a number less than 10 on a 6-sided number cube. So the probability that the number is less than 10. All right. So because the options are pretty much 1, 2, 3, 4, 5, 6, those are all less than 10. So it is certain. It is certain that I roll a number less than 10 when I'm rolling a 6-sided number cube or dice, whatever. Okay, your car will start tomorrow morning, or maybe your parents' car. So what is the probability that your car is going to start? All right, so it is likely. It's not certain. Anything could happen, but, cars start almost every single day. So it's somewhere in between half and 100% of the time. So it's going to be likely. All right, so let's get some definitions. We talked about a few of them, but let's actually define them. So event, right, it was right here, probability of event. The event is an action that takes place. Right, so for example, for number 2, the event that's taking place is toss a coin and get heads, right? So if I was looking at probability of heads, the event is tossing the coin and getting heads. All right, outcome is the result of the event. So in this example, the outcome would specifically be getting heads or tails. Okay, the likelihood is how often the event will occur, right? So the likelihood of getting heads is like should be 50%, 50% heads. So that's the likelihood. The event should occur half the time. All right, and then the sample space is the list of all possible outcomes. So in this example, the possible outcomes is heads or tails. Right? If it was the dice example, then the sample space would be 1, 2, 3, 4, 5, 6. Yeah? All right, to the second page. Usually we only have one page of notes, but this is, probability is a little more like word heavy. All right, this looks like a lot, but it's not that bad. So we have two different types of probability. We have theoretical probability, which describes how likely it is an event that will happen based on all the possible outcomes. It is what should happen and uses the ratio probability of event equals number of ways event could occur and then the number of possible outcomes. So if you remember from the front side, it was like successes over total attempts. This is like should be successes over total attempts. And then we have experimental probability. All right, experimental probability is the probability based on experimental data that are found by repeating the experiment several times. So it is what actually happened. So sometimes you expect something to happen, but it doesn't actually happen, right? Okay, so this is the number of times the event actually occurred, and then the number of possible outcomes. So let's compare the two. Okay, so we're back with our dice. Roll a 6-sided number cube 140 times. How many times should you get a 4? So we're going to do probability of 4 equals 1 over 6, right? Every number you get a 1 in 6 chance of getting it. So if I was to turn that into a decimal, let me get a calculator. All right, so you can't even see it that well. 1 second. Okay, so we do 1 divided by 6. That is 16, move the decimal point 2 over, so we get 16.6. I'll just put the line over it, or you can do 16.7%. Okay, so 16.7% of the time I should get a 4. Remember, when we are doing successes over attempts, so we're going to do something from 9, unit 9. So we have 1/6 equals, how many times my x over 140. So we're going to cross multiply. We get 140 times 1 equals 6x. 140 times 1 is just 140, so we're going to divide both sides by 6. 140 divided by 6 equals 23.3 times. So I know it's not a whole number, but on average, if I roll my dice 23 to 24 times, or like when I roll my dice 140 times, I should get a 4 23 to 24 times. So we're setting up our probability, and then we're doing cross multiplication with our successes over attempts. So this is what should happen if I roll it 140 times. Now we're going to talk about what actually happened. So for this, we have probability of 4, and they told us we roll a number cube 140 times, 28 of them landed on an 8. So if I do 28 divided by 140, let's simplify that. They're both divisible by 14, so 2 over 10, 1/5. So I don't even need a calculator. This is 20% of the time. I don't actually need to do any math. I just need to observe and make comparisons, right? So this is higher than expected. All right. What should have happened, right, the theoretical, is it should have happened about 16.7% of the time. But what actually happened when I did an experimental probability, is that it happened 20% of the time. So it's not going to always, right, if you flip a coin, it's not going to always 100% be like half heads, half tails. But that is what should happen. That's the theory. And then what actually happens is the experimental probability. So this is just an example of the two different types of probabilities. Okay, last example is with M&Ms. So you got a pack of M&Ms and you count and record how many of each color was in the bag. So remember, we're always looking for like total. So we want to find the total amount of M&Ms. So if we add them all up, we get 8 plus 10 plus 5 plus 7 plus 12 plus 6 plus 0. So 48. So 48 total M&Ms. So now we're doing, this is an experiment, right? We actually had these M&Ms. So what is the experimental probability that you selected a red M&M? So for this, we always do the actual over total, right? Or like, you know, successes over attempts. Those are all sort of the same thing. Okay, so we have red. We have 8 over 48. So we want to simplify that. They're both divisible by 8. It's 1/6. So this is it. This is our answer. Not that hard. The experimental probability is 1/6 that I'm going to get a red M&M. For yellow, I'm going to get 5 over 48. You can't simplify this any further. So that's my final answer for yellow, right? I have my actual, there's 5 yellow over my total 48. All right. So probability of probability of green or brown. When it says or, we add it. So green is 12 plus brown is 6. So we get 18 out of 48. Okay, to simplify that, we can divide both by 2. We get 9 over 24. Divide both by 3. We get 3 over 8. So this is our simplified version. Okay, so the probability of getting purple, it's 0 out of 48, which just simplifies to 0. Okay, probability of not orange. All right, so you can add up everything but orange, or if you want to do a shortcut, you could just subtract orange. All right, so if I'm just going to subtract orange, I'm going to do 48 minus 10 equals 38. So 38 over 48. That simplifies to, dividing them both by 2 is 19 over 24. All right, our last one, the probability of blue or red or green. All right, so for these, we're going to add them all together, right? 7 plus 8 plus 12 equals 27. So 27 divided by 48. We can actually simplify that. They're both divisible by 3. 9 over 16. So this is probability. It's just actual over total or success over attempt. The one last thing that we might want to do is turn these all into decimals. So if I have 1 divided by 6, that is going to be 16.7%. If I have 3 divided by 8, 37.5%. 0 is nice and easy, it's just 0%. 9 divided by 16, we have 56.3%. Remember, if we're rounding, we move the decimal over, this last one gets bumped up by the 5 there. So you need to make sure you're rounding right, you're going to get some points off. 5 divided by 48 is 10.4%. And then 19 divided by 24, 79.2%. So if we look at these, for example, the most probable thing of happening out of these 6 situations is not orange, right? Not orange is a 97.2% chance. It's pretty high. Probability of getting purple is low. It's never going to happen, 0%. So you want to be able to go from both fraction to decimal. You're going to need to simplify them, but you can use a calculator in this unit. All right, so that is it for probability.